Okay, so guys, welcome to a third day of design and structure for 31 days. I'm going to start sharing my screen, but before we get into the session, I would like to show you just a simple trick that um, you might find useful. Recap of yesterday's. Okay, so Paul is asking, can you do a quick recap of yesterday's session? It wasn't very clear, it was difficult to understand. Okay, that will be the first thing that we do. But before that, because I haven't shared the PDF in the WhatsApp group. So what I'm going to do is I'll show you how you can convert from PDF to DWG and then back to PDF, because that drawing, it's got some information that I do not want to share publicly because of the person that designed it, the architect. It doesn't belong to me, so you know. So if you've got a PDF drawing such as the same one that we have the sample, let's see. I'm saving it in here on the desktop. Oh, someone is requesting to join. Okay, Niza. Yeah. Oh, we only have three people. Oh, I thought Niza was admitted. Okay, so we have this sample here. Uh, this one, PDF images and PDF images. Oh. So we have this thing that we are going to be using. The sample. Close this, close this. So because it's got a title block with some information that I do not wish to publicly share, I'll have to crop it. I can either crop it using other software, or I can crop it in AutoCAD. So that's what I'll do. I'll open my AutoCAD since I already have other information. Let's see, let me do this. Here, if your AutoCAD is open, you can click a new drawing there. This is a new drawing, you see. Oh, okay. So like I was saying, here we've got a blank drawing, an empty space. On you've got home insert. On insert here you go to PDF import. There you've got this select PDF file dialog box. So now you have to locate where the PDF is. For me, it's on my desktop here in this folder that says 2025 March Madness teaching material 31 days. Day 1 in the PDFs, the sample. So when you click open, there's the import PDF. You cannot, because it's got 3 pages, you cannot import all of them at once. You have to import. Okay, so I hope everyone can hear me. What we're doing right now is that we haven't started the session yet. I'm just showing you how you can convert from PDF to DWG, then back to PDF, because I'm yet to share that drawing that News had requested for. So if you've been following the video, you go to insert in AutoCAD, you open a new drawing, you go to insert, or you can use an existing drawing, it's fine. But for this example, I decided to use a new drawing. So you go to the insert tab, you go to PDF import, you locate the PDF which you wish to convert to DWG, and then when you open it, it brings up this import. You import PDF. So when you click on page 1, so the drawing itself has got about 3. It's got 3 pages. You cannot import all of them. You have to import each page at a time. So page 1, you click it, you say okay. There it says specify insertion point. You can click anywhere in your drawing, and then it will import the. It's taking a little longer. There, you see at the bottom there you have the drawing that you need to. I'll do that again for page 2. there, sample. This is page 2. Okay, I'll go there. I'll import it. Now I've got 3, you see. And then the last page, you repeat the process. You select page 3, you okay, you select the insertion point, and it inserts there. So now I wish to crop out certain information. What I'll do is I'll go to the this print icon, and then I'll set up the page. Here the printer name, I would like to change it to a PDF. If you wish to print it to a physical copy, you select a printer if it's connected. For our office OB and I, we've got this Canon TS, but that's not what we want to use. We want to change from Microsoft to PDF. So I select it. Actually, I want it to be high quality, so I'll go AutoCAD PDF high quality. You can also choose this one, it's okay, but for preference sake, I usually use this one. And then the plot style, if it had a lot of colors and you only want black and white, you can do grayscale monochrome or use monochrome. It asks you assign this plot style to table to row layout. I'll say yes, because I do not want to be repeating the process. So I'm basically just creating a template. I'll put this on an A3 sheet in landscape. Oh, sorry, A1. ISO A1. I've got an A1 sheet here. This one is landscape. The other ISO, where is it? Here. This one is portrait. But I would like to use an A1 sheet here. Where is it? Here. Yeah. And then I would like to use a window selection. I do not want to create layouts because I really want to do it real quickly. I'll select window, and then you select the extents. For me, I just want to crop out the border, so up until there. And then I would like it to fit, and I would like it to center, you see. And then I'll apply this layout, and then I'll preview. See, it's cut out the title block, and it's only left the area that I need. And then I can click on the print icon. I select the destination. Previously I'd done one page. I'll just rename it as 01, right? Full stop. And then I'll save it. And right there it automatically pops up in the viewer, the PDF viewer, right? So you repeat the process for page 2 and 3. Just close this, close all, and then I'll go to the printer again, window selection, select the extents from there to there. You can preview, you can press OK because you've already set it out. When you preview it, this is how it's going to come out on an A3. Then you print, you say 02, then enter, it regenerates there. You close. For the last page, you repeat the process. Window, window selection, page 3, there to there, and then you preview, then you print, you name it as 03 and enter. And then someone is requesting to join. Okay, okay, so after this what you can do is you can combine them. I use an online combine. Okay, just combine. This is some work I've been doing previously. So let's just wait for this to finish. If you wish to combine your PDFs, this is the online website that I use. It's called Combine PDF. Other people use Adobe. Is it Adobe Pro? And I think also the Yeah, Adobe Acrobat, but the pro, the regular one doesn't combine. And also you can use what is that? The reader that we often use here at the office. What's the name? WPS. It's taking unusually long. Okay. Oh, Mundi. Hey, Mundi, are you good? Oh, you muted it. Hey, good evening.
Good evening.
Hey, you're good?
Okay, da, okay, da.
Okay. So we haven't really gotten into the session yet. I was just showing how to combine a PDF. Okay. So as we wait for this one to finish, we can do a quick recap of what we did yesterday. So from day one, let me just open my prod. So this is how the drawing should look after we are done, right? Um, I'm still using Prota 2018. Mundia is more advanced. He's using like 25. So just close this or open a new file. Open project. This one. This one is the one that we're using here. Or let me just open. Let me close and open so that we start from the beginning. Maybe I can share the PDFs as they are, page at a time. Where is it here? Um, so guys, if you wish to follow before I combine, there's this 01, 02, and 03. I'm sharing them in the group. Just confirm once you receive the drawings. I'll combine them later and share them so that we do not take a lot of time waiting for them to combine. Niza. PDF files. Okay, so we can get
They've
into
come.
the come, right?
Yeah,
Okay,
thank you.
all right. So you can go through as we start. So on your desktop, if you've already installed your Prota 20, whatever version, 2018 and upwards, you should have a shortcut there on your desktop. You double click it, it loads up. I'm using 2018 like I mentioned. Hope you've downloaded your Prota, guys, together with your AutoCAD and Revit. If you've managed to download the software, just comment on the Teams here, the chat section. You can comment. Oh, Lucia, you cannot see the screen. Guys, can you see the screen that I'm sharing?
I'm able to see your screen.
Okay, means I can see.
Yes, I
Yes,
can
I'm
see
able
the
to see
screen.
your screen.
Okay, Paul can see it also. It's visible. Okay. Eh, our friends. Mukubeza, you downloaded 2021. Have you been able to install it? Okay, so when you
I
open,
studied before, but used it for I used
ah,
it at some point, but
okay, that's nice. So here on your, once you load Prota, the open project, it shows some files that you've already worked on. For me, I was working on Mwaka's thing, so it's already taken me to that. You see, when in the address bar here, you can see it's got all these slashes. But then, what I really want is this one, the 2018 folder, where the other stuff is. And then 31 days is what we've been working on. I click on it, I load it, it starts up, and then yeah, in our previous session, we had tiled them in a horizontal. So if you wish, you can change them into vertical like that, so that you can trace them like that. So a recap now, Paul, like you had requested. What we did. Oh, let me close this one. Let me just have one. Okay. So in day one, what we did was we created grid lines, right? And we renamed them. We created grid lines in the y direction here, and also in the x direction. And we did this according to the PDF. According to the PDFs here. Number one. So this drawing was previously done by, it was initially done by an architect, and then they proposed where they would want the layouts to be here, where they propose where they think the columns should be, and also they propose the dimensions of the bases, like 1515, the columns are 400 400. So ideally, if you're a structural engineer as opposed, or if you're a structural engineer as opposed to an architect, you need grid lines so that you can reference your structure elements like bases, columns, beams. For example, if we didn't have any grid lines, it would be difficult to identify this column. What would you call it? Unless maybe if you've numbered them as C1, C2, C3, or any type of identification, it becomes easy. But an easier way is to have grid lines so that at the insertions or the intersections, if this was A in the y direction and this is 1, it would be y1, a1, or 1a, this. So here we inserted grid lines like that in the x direction where we thought the grid line should be, and also in the, sorry, that's the y direction and x direction. And then this turned out to be this here, you see, our a, b, and so on and so forth, and also our 1 2 3, you see, like that. So that's what we did in day one, and I think we also added some stubs. We also had shown how to change the names of these grid lines. You write, when you select it, it highlights, it changes the color. Previously it's blue. You select it, it becomes red. You right click, you've got all these options that come up. When you go to properties here, you can change the name according to the label. So this one is labeled A. It also shows you the length. It shows you the angle. It's at 90 degrees. Previously in lesson 1, I had a problem with one of them was skewed. So another way in which you can identify whether or not your axis is skewed, for example, if I draw something like this that presumably looks as if it's at 90, can you see the angles here? Showing the length, the angle, and also the delta x and y. So for example, if I thought I was drawing a straight line, but which actually wasn't like that, it looks straight by looking at it, but it's actually skewed. When you click it, you highlight it, you right click, you go to the properties, it shows it's at 89, it's not perpendicular. When you start analyzing a grid line that's skewed, you're going to have problems in the future. This is something that has happened to me before, and hopefully, I hope it happens to you also so that you can be able to learn from it. So, yeah, that's what we did in lesson 1. I also showed you how to add levels on the building setout and edit. You can change the heights. Usually in Prota you won't have a section like Revit. You won't be able to create a section. So this is what you're going to need to use to have levels. So you close, and then I also showed you how to move from plan to 3D. You click on the views there, story 3, you right click 3D, and then you use your right mouse button to change, to switch, or to rotate like that. And then I think we did the stub columns. I don't know if you guys know how to insert columns, but that's something that we did in day one. The concrete columns were in day one. Day two was the steel columns. So for the purpose of this lesson, because yesterday's video was really trash, what I'm going to do is I'll go back to ground level, change to plan, and then I'll delete these. They're actually on the wall plate level. I'll delete these beams, these columns, the steel columns, so that we can just maximize this window. So if you wish to only select, like you can select this, but you selected everything, including the columns. Yeah, including the grid lines. But what you really want to do is just select the columns. So what you can do, there's a filter button here. It says filter selection. When you click on it, you can deselect and then you select what you wish to select. In my particular case, I only wish to select columns. I click on it, I deselect it like that, and then when I click everything in this, oh, okay. When I click like that, you see, it only selects the columns. Just make sure it's active, not the way that I took it back in the background. So now I can delete everything. And then it gives a prompt like, do you want to delete the columns? If I okay, all of them are gone, right? I deselect it to remove it from my view. I click and then change to 3D, and then you see I'm only left with my stub columns. Yeah. So, oh, hopefully oh, is it still in? It's not. It's gone. Yeah. Actually, a lot of people have gone. So that was what we did. That's a quick recap of day one. Day two, mm, network. Day two, we inserted the columns, the steel columns. So now, usually these design softwares, and also according to what a friend of mine told me, Mark, what usually happens is when you're placing structural columns, not those architectural pillars, the way that design softwares read those softwares that you are placing from the top and it's going to the bottom, as opposed to architectural columns or architectural walls where if when you place it, it reads from the bottom and going to the top. So you need to be very mindful of your oh, yeah, so you need to be extremely mindful of where you wish to begin to place your column. So for my case here, let's see, I've got that section view. I think it's number 3 of the architecture here. Oh, it's number 2. Yeah, and let me put them in proper order. So number 1, number 2, number 3. So number 2, here we've got the architect's levels here. They say the ring beam is at 2.6. The ceiling is at, I do not know, but we'll put it at 4, or we'll put the wall plate at 4, so that the height of the room from to the soffit is 4 meters. So what we can do is the eaves. If we go to the building set out here, let's make sure it's about 4 meters. This is the wall plate, right? It's 4. That's the level. Meaning, if I place a column from the wall plate going down, it will only go up to the ring beam because the ring beam also has a level. And let me show you what I mean. So right now I'll select like that, and then right now I'd like to have another view so that I can have them in side by side. So I go to view, right click, I'll say a plan view. Now I have two, and then I can set them in a vertical. I'll tile them like that. So I know for a fact that here and here and here I need to have a column, right? A steel column. So what I'll do is I'll go to this is the column button. Uh, I'll click on it, and then I have this pop-up that comes. I can actually bring it in my work area like that. I can place it there. So I need a steel column and not a concrete. So I go here, this button that says section manager. I'll click on it, and then here in the drop down, what I need is a steel column. I'll click on it, and then there are a lot of uh, steel sections and beams depending on what type of code you are using, right? This is the BS, British Standard, the British standards. You can see the English flag, and then this is the Euro, according to the Euro code. Or maybe this will be Imperial American. American Institute Steel. Oh. And then I think that's Malaysia, Singapore. So for me personally, I would like to go into the British standard, and I would like to use a universal column, right? Not a universal beam. So I'll click on UC, meaning universal column, and then since we're designing, I can choose whatever beam that I desire. And then we'll run an analysis. But also bear in mind, when you're selecting a steel column, bear in mind of where you're placing it. You're placing it on a concrete column. What is the dimension of the concrete column? We're using 400 by 400. So now imagine I've got a 400 by 400 concrete column, and then I'm placing another maybe 406 here. That's too big. How about because it needs to sit on a plate, and then also the anchor board. So maybe if I desire to wish a bigger column, maybe I need to design bigger stub columns, right? So for the purpose of this video, let's say I want a 303 by 283 kg. When I select it, it's a reasonable, though it's actually quite big. Select, select. So I'll start placing them. Remember, I'm placing them on the wall plate, going down, and observe what happens. Let me just accept. Oh, okay. So observe what happens here, especially in the 3D view here. You will notice that it will come from the top, even now when I try to place it, you see. Starting from where the eaves is, going down. So when I click it there, you can see in the 3D view, it's starting from the top, going down. I'll place another one here, top, going down. There it is. I'll place another one there, and then where else? Here and here. This is at C. There and there, right? Also here I know for a fact there are 3 stubs there. Where are we? That was D. Okay. D has got 3. Yeah. Anyway, we'll delete the ones that do not have any stubs later. So we can place them like that, like that, like that. And then F doesn't have any. F has one at the end there, here. I'll place it there. I also has one. Oh, that's J. Yeah, this is confusing me. Anyway, let me just place them everywhere, and then I'll delete where they are not. Like that, like that, like that, like that, like that, like there, there, and then there and there. And then I'll update and close. Okay. So now you can see that this is only ending up to the ring beam here. You see. Why? Because how Prota reads it is that you're starting from the wall plate and you're going a level below. And the level below is the ring beam. But that's not what I desire. That's not what I wish. I wish for it to go up until the ground. So the ground is here, you see. But then now you have to do some simple subtraction. If the ground is at 300, it's at 300, isn't it? According to the building setup, it's actually 200. You can see here. If my ground level is at 200, and then my wall plate level is at 4, right? So we're talking about 3,800 difference, right? So let's try that. So you can cancel. You can select one like that, and then you right click. You go to the properties. Here there's a 3D. You go general. You go to drop for those column drops. If you're designing flat slabs, there's something like a head. Or let me try to show you. Um, column drop panel. This is a drop panel. Something like this. So you can also design a drop using Prota. I remember when Mundia and I met, we met at the King's Hospital. And then at the King's Hospital, they also used flat slabs. And then as a habit, Mundia used to tease me and say, what is the purpose of these drop panels? And by then, I really didn't understand them properly. And then you'd say they're for the purposes of punching shear. Because these flat slabs do not have any beams. So the thing about a flat slab is the characteristics is that it doesn't have any beams, boundaries. So you need this drop panel so that the columns do not punch, right? Like that. But then, okay, so too much. So let me go to where here we are trying to reduce, right? We are trying to reduce from the wall plate to the ground, and we've estimated that it's about what 3,800. Yeah. So here on delta z, it's going down. So I'll add a negative, and I'll say 3,600, and then 3,800, right? And then I'll update it. Let's see what happens. Let's see. You see, it sits exactly at the top. When I exit, but it shows that it's going down. You see, it's gone further down. So how about I reduce it by like 400? Edit. No, I select it. Right click. Properties. 3D 3000. Let me say 3,400. Update. Exit. Still fine. Okay. How about 3,000? So I don't know the arithmetic there. That's something is requested to do. Okay. So let's try 3,000. Okay, let's try 3,000. 3,000 altogether. Uh, okay, see it's reducing. So therefore it should be 2,800. I don't know what I did with the levels there, but you need to make it work one way or another. You see, why am I going back to the same? Select it, right click, properties, 3D, 2,800, right? Let me say 2,800, update. And now, hey, there's a small one there. So let's try 2006, right? 2006, update. Okay, let's zoom in. There's a small space there. You see it? So that's not an end joint. So your analysis will probably be not accurate. So I think by estimate that's like 100. So I'll say 2,700. Yeah. So OB is a small one also. Whatever. So OB is asking where the math is. Let's try to look at it again. Oh, okay, I understand. So because we were placing it on the wall plate and it's going to the ring beam. So from the difference between the wall plate and the ring beam is what we had at the beginning. So now what we need to subtract is the ring beam minus the ground, right? So the ring beam is 2820. Let's say pull out my calculator. 2820, right? 2820 minus 200, right? And therefore it should be 2620. No, you can start from there because now you've subtracted that. Yeah. How much? 2620. So you see the protrusion there. I think that's 200. So properties minus 2620. 2620 update. And now this is perfect. You get the math right. Now you're good, right? You see, now it's sitting properly. It's not even intruding.
Got a question.
Okay.
So the way it was protruding into the stub column, when
Mm.
you are doing an analysis, does it distort the figures? Does it change the
It
analysis
it does
compared to
because
when it's flush?
yeah, because when you're so his question is suppose it gets into the stub column, how accurate will the analysis be? So in structural engineering, if you've done structural mechanics before, or yeah, structural mechanics used to say there are things called end to end, right? So for example, according to the connection type that you have, these we usually model them as fixed end. So in order for it to be fixed, it has to flash. Otherwise, if it's entering, then it's not an accurate connection. And if you, oh, Mundia's got a question. He's raising his hand. And there's someone that wishes. Okay, Mundia.
Yeah, so it's actually a contribution.
Yeah, please go ahead.
So Prota is actually intelligent. So when your steel column is protruding into the
Stop.
concrete column,
Yeah.
it won't actually analyze. It will tell you as you do a building model check. It will tell you that in that case, if the stub column is maybe 1C5, it
Yeah.
will say that 1C5 and 2C5 are clashing. So it won't analyze.
I do not believe you.
Give it a try. Make it protrude and then try to analyze.
Whoa, now we've created levels. And so, I have to populate all the levels in order to
Yeah, you
actually
have to, you
analyze.
have to, yeah, you have to, yeah, I guess.
Yeah, so for
But
now,
we'll get to that stage anyway.
so now you've been a featured instructor. When I don't know if you've got time tomorrow, I would like you for you to show us what you mean. I won't believe you until
Yes,
you
I,
show
I
me.
will.
Yeah, so
I
for me,
will. I will show.
for me, I won't believe you until you show me.
I, I could actually show with the current project.
Oh, you can share screen.
Uh, maybe. If now is okay.
Oh,
If I
sure.
can share now, that's fine.
Share.
Maybe
Okay.
we'll be jumping the gun by running an
Oh,
Yes. So
analysis
I
now.
think
It was just
at the
so
end of
later,
the
later stage.
yes later stage. Yes.
okay, okay,
Okay.
okay. So that's a very good observation, Ninja. Whenever you try to do it also as you practice. But let's remember we've done minus 2620, right? So I can go one by one selecting these columns and say minus 2, 6, 20, but you understand, right? Uh-huh. So I can go one by one, changing, but that will take a lot of time. Like Mundia said, Prota is intelligent. That I believe. Whatever else he was saying, I do not believe. So what we can do is, I'll select the steel columns again. First, I'll click the filter. I'll select the steel columns and I'll highlight so that I only select my columns, you see? And then I'll right click and go to the properties, and it brings this column table. And when you look at the column table, it has a lot of information. Information number one tells you on which story the column has been inserted. In this case, it's story number 3. Also here, if you can see my cursor there, it says story number 3, and all of them have been highlighted, you see, from C1 to C9 there, and everything in between. And then it also tells you the name of the column according to the placement in this case. It tells you the B1 if there's an eccentricity, B2, E2, whatever, and then our particular, what we like to take interest in is the delta, or the difference, right? Because X is the X direction, Y is Y direction, Z is the depth and height. So the top, I want it to maintain 0 because that's where I inserted it. The bottom is the one that I would like to change, right? To go down. And so I would like it to go down minus 2 meters 620. So I do not have to go one by one inserting minus. I can simply, if you've used Excel before, you just click the top of the column like that. It highlights everything. Then you type in minus 2620. When you enter, all of them change, you see. Like this one, this side. You can see on the red. And then you can close. And now everything is flashing like that, you see. You see, and it's except for where we did not place them. So for example, this one doesn't have a stub. You remember I was just placing them haphazardly at the beginning. So this one is not important, I can delete it. This one also is not important, I can delete it. The other one also here, I can delete it. But these two, I think this is it H and I here. Oh, oh, this one here. Okay, so this one I can delete it. On the right, yeah. On the left, this one. Oh yeah, this one also. Okay. So I need two steel columns here at H and I. If I go to my 3D H and I here on these two areas. So another way that you do not have to go back to your, let me deselect this. You do not have to go back to your column so that you can start placing. You can just get one with, remember we've made changes to this one, and this one is at minus 2620. You can use that to your advantage. You select it, you right click, you go to your properties. What this means is that you are placing a column here with the properties exactly. So now you just, okay, let me go to the 3D so that it can be seen. Okay, you select, you right click, properties, and then when you place it here, watch in the 3D area. You see, it sits exactly at the top of the stub here. You do the same here, like that. And where else? This is on L. Eh, Monica. Okay. L. Where is it? Oh, here. So I select a column that's near it. Properties. L here. It sits. Where else? The last 5, right? Meaning right click, meaning here, yeah, here, 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 and here. Uh-huh. So now you've got this structure. I don't know whether I should carry on or maybe we can end the video here or answer some questions if there are any. Did we? Oh, okay. So we did do the truss. Let me do the truss also in this video yesterday. Guys, should I end the video here? Are you saturated or should we continue?
You can place the trusses. That's what we did yesterday as well.
Okay, okay, good. So going back to my program, uh, also, um, general rule of thumb: you're placing your you're placing your truss on top of the steel, right? And where is the position of your steel? It's on the wall plate, right? So bear in mind you want to place the truss on top. And then also there are two types of ways in which you can either design your own truss or you can make the ones that come with you can insert the ones that come with Prota. As an example, let me show you two kinds. If you've ever designed with steel before, you know that a truss will be made up of chords, like top chords, bottom chords, and then you've got those waves, the vertical ones. It can be a Pratt truss, it can be a whatever names. Revit has the names better. Yeah, the spider trusser, the whatever truss, whatever name. So if you like, you can create it. What I mean to say is that if you like, you can create a truss manually, or if you like, you can do it automatically with the presets that come with Prota. So for example, let's insert an automatic truss. You can go to the because a truss you want a steel truss, not a timber or whatever. So you go to steel member. When you click on it, you got steel column, steel beam, steel truss. You select it. It says pick two axes here. Pick two axes and sections for member insertion. Okay. So what I would like is I would like to place one from here up to here. And then it brings up this truss generator automatically. And then here the view you can change if you like a wireframe, like an analytical one, or you deselect it a 3D. Actually, something that other people do not know is that this is actually a 3D. You can hover like that, and then just by looking at it, it shows me that this is an L. It's an angle. This truss is made up of whatever, I don't know this. Yeah, if I go to geometry, maybe members, it will tell me the 100 by 100. You see, but also here in this picture. But this is not the kind of truss that I wish to use. I would like for my structure to have a gable type of roof, and therefore I go back to the geometry. I select this truss, and then it's got a variety, right? For me, I would generally just like to use this one. It's much simpler, and also because of the number of triangles, like the triangles look more, triangles will probably be more stable. And then now let's change the members. I want my truss to be made of the top course to be of maybe IP200. Also, another thing that I would like to advise you guys that read as many structure drawings as you can, or read as many design codes as you can, so that you get a general idea of what these truss members are made up of. The ones that I've seen usually, because serviceability, a structure like that one, you're only going to be accessing the roof if you need to maybe repair it, right? But if you're going to be accessing it for other, maybe if you intend to put heavy things like maybe a geyser or maybe air conditioning, exactly. So maybe then, because of the dead load, you would want to have stronger members. So for me, I'll just use an IP200, right? I go to members. Here you can see it's got a top chord, bottom chord, diagonals, verticals. So I'll say for my top chord, I select it. I would like an IP200. An IP200 is used in the Euro code. There. In the Euro it says IP. And then you've got all these. You can even use 100. But for this, let's use a 200. Like that. You select, you update, and you can see that it changes. Before there were angles, right? So now I'll go to the bottom, and also here it updates. Says top center, what. Here I'd like to use also an IP. It's in the Euro. IP 200. You select, you OK, and it shows you. If you would like to have more information regarding maybe the inertia point, further information, the profile, I think you can go to here, the section name and properties. It gives you all this information like the area, the moment of inertia, and all that other, the modulus of elasticity, and all that other good stuff. And then I would like my vertical also. If you will not be using a hunch here and you'd like the top chords to be supported to transmit the load into the bottom chord, then maybe the vertical needs to be stiff also if you're not going to have a hunch. So for this one, you can, anyway, to make the video short, I'll leave it like this. And then when you're okay, it's, when you go to the 3D, you see, it's already inserted. And then this truss is specifically good for if you like a bonus. The roofing sheet, that's good there. The bonus thing. Yeah. Let's see if I can search for bonus. Like a cladding, a side cladding here. You see? Yeah, so you can keep that. And then you put some purlins on the side so that you can have somewhere to anchor those nails. Something like this. Like that. But if that's not your design, you can go back, you can select the truss, you select it, you go to the properties, and then you can make these the left, the HR and the HL, you can have them go to 0. You see it reduces there. Also here it reduces. You select, you OK, and now sitting directly on the column. Am I still live? Okay. Yeah, I'm still live. So that's one way of adding a truss automatic. Another way is where you actually just design one yourself. So here on C, grid line C, I'll go to C. I would like to use maybe universal beams. So I'll go to the beam there. I'll go to the section manager. I'd like to use a steel beam. And then let's say a UB. I go to back to the British. A universal beam of maybe 203, 203, 203, 133, or maybe 30 kg. I select OK, and then when I click it, if I put it there, you see it's straight like that. And then I can add another one here like that, and then I have two, right? But then I can give them offsets. I can offset them upwards, for example, in the Z direction. Exactly. I'll right click, properties, 3D. Now you've got I and J according to the beam placement. So my I is the beginning, my J is my end. And the way that I was placing it, I started from here, then I went here. So this is my I, this is my J. I deselected it. Okay, let me select it again. Because I'm running out of time. Okay, the video might just cut because we only have about 60 minutes. So if I select this, I go to the 3D, I go to my J, and maybe I give it like what's a reasonable 2000? Yeah, 2000, 2 meters. Ah, it went. No, it went to the. Okay, that happens, guys. Meaning, Prota is reading this as my beginning. So instead, I'll put it here. Then when I update it, it goes like that. And then I select this also, properties, 3D, with the same measure, show this 2000, so that they meet, they are at the apex, like that. So this is according to the way that they were meeting. If you'd like them to meet in the center, you probably need to put a grid line somewhere here in the center. For example, is this too much? Should I proceed?
Yes, you can proceed.
Okay. So let me just add the mid axis. I select. Remember, if you wish to create something similar, in Revit they've got that create similar option. Proto works the same way. If you want to create something of the same nature as something that you've already created, just go to that item, right click it and go to properties. What that means in Proto is that you are creating something of what you've created in a similar manner. So in this particular at this particular moment, I would like to create an axis in the middle, right? But yes, let me measure. There's a measure tool there from here to here. It's telling me it's 11,930, right? So what is 11,930 divided by 2? It's 5,965, right? So I want to place a grid line at 5,965 so that it can be at the middle. So I'll click what I wish to create. I'll right click it. I'll go to properties, and now, eh, sorry. Oh yeah, I needed to go to the offset button. So right click, offset. I'm going in the down ones, right? So to activate the numbers, you shift F2, and then we said 596 what? 5965. So you enter. Eh? I think it's cut. Yeah, it did cut. Dismiss. Create another. Get link. Yeah, still recording. Okay, copied it. I'll paste it in the group, and I'll say this is the link to the new video. New meeting. The old meeting, it ended at 6. Yeah, I lost after 60 minutes, right? So we do how many? 10 more minutes. Let's do 10 or 20 more minutes. So I go back. I start. Mm. Okay, so don't know whether to proceed. Okay, guys, let me continue so that the video is not too long. Otherwise, for everyone that was left out, that was cut out, you can be able to continue using the video recording, right? So Mkubeza is already here, Po is here, For other people, Mundia was initially in the meet, and other people. If you will not be able to join us within the next minute or so, then you just have to go back and watch the video. So going back to share. Let me share the screen again. I'll share the entire screen. Okay. I'll hide. So now what's happening is that where were we? We were trying to offset, yeah, to create a midpoint at 5965. So like I was explaining previously, what you do, you go to what you wish to create. You select it, you right click, and what do you wish to do? You wish to offset. And where do you wish to offset? Do you wish to offset downwards, upwards? Upwards is a positive, downwards is a negative. Bear in mind. So you say, it's not activated. So shift F2, you say minus 5962, right? But, 5965, you enter, and then you've got this point 4. But I do not wish for this axis to say 4. I would like for it to read midpoint or mid. So I'll select it, right click in the label there. In addition to numbers, letters, what you can name them, actually give them actual names. So for this one, I'll say mid, right? And it will read mid. Yeah. Also on the other end here. Because I do not like the way this one was. Someone wishes to join. Yes. Okay, guys. Nisa, you are behind a little. You have to go back to the recording. But initially, essentially what I'm trying to do is I'm trying to put these in the middle so that they can form a proper truss. This one is a little, it's not very good. Yeah. So I'll delete this so that I can recreate. We did the automatic truss, we can do the manual truss now. So like I was explaining, whatever you wish to create, if you've created something similar, just go to it. If you haven't, then you have to go through the process. But I wish to create a universal beam. So there's already an existing universal beam in this session, this drawing. I select it, I right click, I say properties. I wish for it to span from C1 there to the mid, like that. Okay, and then this also, I'll delete it. I wish to create something similar properties. I wish for it to start from C3 to mid. At first you say, what is this guy doing? Like, can't you see that they're going in the opposite direction? This one is in the correct direction, right? But then this one is in the wrong direction. Meaning, you go to the properties, 3D, and then you make the relevant adjustments. Meaning this one will be 2000, and this one will be at 0, right? You update, and there you have yourself a manual truss. This manual truss, of course, here it will need some end connections, like an end plate, right? And then also here, something that you can do in Revit, like let me just show you quickly. When you go to Revit 2024, Revit creates these connections. Prota, you'd have to analyze and go to Prota still, and then you start placing them. Yeah. So in the future, anyway, I'll show you later these connections in the future. But for now, I think we can end our video here. So in this video, we placed the steel columns. First, we explained that Prota and other design software, they place columns according to the depth, not the height. So the level at which you wish to place it, it will go down. So bear in mind. Number one. Number two, what else did we do? We inserted the truss, then we changed the automatic truss, and then we changed the members These where IP is, and then the top codes where IP is, and then these we left them as the angles, the L's, and then the manual truss. So you've got the IJ, right? And then in the future you'd have to create connection points, something like I think I'm working on something with, was it? I think it's this. So yeah, something like this. You see, this is a connection. It shows the welds, and you're using a nameplate. This is a view with holes, and then these are the boats, and it's got a roof apex. This is the Yeah, this is an apex haunch, and then this is the side haunch. It's cut from the beam. You use a simulator, you cut it in that shape, and then this is the view, the elevation view. This is the section, and then you can use 6 millimeter welds, and then the channels, the purlins will sit on top, and then you can bolt them down to the IPE like that. So here you have a proper support. Yeah. So when we finish, we should have something like this at the end. So I'll end this session, this video here. If you guys have got any questions that you'd like to ask in this video, you can ask them now. If not, just tell me, we can end the session. You can tell me we end here, and then I'll upload the video on YouTube. Any questions, guys?
No questions. Thank you very much.
Okay, okay.
No questions, Mr. Thank you very much.
All right, you're welcome. How are you?
I'm alright. How are you?
I'm good.
Thank
Mugubesa,
you.
you got any questions?
No question, no question.
Okay, guys, then if there are no questions, then see you tomorrow, day 4. Please review whatever we've learned so that we can be on the same page.
Okay, thank you so much. And share both videos, the recordings.
Oh, yeah, definitely.
Alright.
Okay, it's just one video. What cut was the team? The video kept on recording, so it's just one video.
Okay, okay. Thank you so much.
All right, all right. Bye bye, guys.